Hi.
Morning.
Morning. Hello, everyone. You guys have a calculator with you. I think there was some left on the desks today. So please, please, please make sure you have a calculator. Turn it on to make sure that it's awake and working. And if what's on the screen is like, what? Go ahead and clear the memory. You are my fantastic fourth period class, and today is the 24th.
Third.
All right, these notes are for Unit 12, Day 11. The title got cut off, sorry. We're looking at quadratic inequalities. Quadratic inequalities are no different than quadratic equations, except our answers are going to be less than or greater than. And we're probably going to have to draw something at the end and then shade it in. But other than that, all the rules are the same. You're going to solve the inequality as if it were an equals. You're just going to be mindful if you multiply or divide by a negative that stuff is going to happen. And don't worry about it on the quadratics. We're going to solve the quadratic normally using either factoring or completing the square or quadratic formula, your choice on each one of these. And then we're going to run some test points. We're going to color some things. It's going to feel like kindergarten. And that's it. We're done. Ready? All right, let's do this. You can graph the answers one of two ways. You can graph it off of just a single variable, such as this one. And it's going to look like a line. Okay? So this tells you all of the possible x's that make 0. Or you can graph it on a grid x, y, and look at all the different possible points of x and y that make our inequality statement true. Okay? We're going to do both of these today. All right, let's look at this one. I don't know why it's number 3, but it is. We're going to solve this thing. Okay? To solve it, what we're going to do is we are going to pretend that inequality sign is an equals, and we're going to go equals 0, and then we're going to leverage one of our 3 techniques. We're either going to factor it, complete the square, or use the quadratic formula. No one cares which one you pick. Which one would you like to see me work on first? It does look familiar.
Oh, wait, you said yes.
What would you like to use to solve this one? If you've been practicing your factoring, it's entirely possible that you're seeing the factors of this already. Try to factor it in your head. A times C. Factor pairs of that. Is there a pair that add up to the positive 3? A negative 2 and a positive 5. All right, because this number here, hey guys, thank you. Because this number here is a 1, I can do this. And so if you've been practicing your factoring, for many of them, you should be able to do that. What we just did. If you're not there yet, that's okay. Keep doing it out the long way. Keep breaking it down so that you can see all those different factors. Keep playing the shuffle game. Now that I have it like this, I can set each one of these factors equal to 0 in order to figure out what the values of x are. They're my values. That was a 0 product property. No big deal, right? Okay. Once we've got it down to this, we're going to go over to the right side of the paper where I have that number line, and we're going to put on the number line these 2 values. They have to appear on your number line. Okay. One's negative, one's positive. You know what? I might as well throw 0 there between them just so that I know where it is. And I'm not worrying about scale. I know negative 5 is further away from 0 than 2 is. And it looks like I've drawn them about the same size. It's fine. It's okay. In order to figure out where on this number line I need to draw, I've got to grab some test points. I have to grab the 2 points that I found in my original solutions. Okay? So I have to look at -5 and I have to look at +2. Just, I have to. Then I have to look at 3 other points. One point needs to be to the left of -5 somewhere. One point needs to be to the right of +2 somewhere. And one point needs to be somewhere in between the two of them. Can I have a number here to the left of -5, please?
-8.
-8, okay. Can I have from someone else a number to the right of 2, please? I heard 3. And then, what number did you say? 4. Okay. If you want to run it with 4, that's fine. I heard 3 first, I'm sorry. But, so that you don't feel left out, can I have a number here somewhere between -5 and 2?
-1.
10.
Looking right over here. 1, okay. 10 would not work. That would be on the very far right side of 2. We want it between -5 and +2. It's okay. There's a lot of numbers going on. I get that it's easy to confuse them. All right. Now that we have our test points, we're going to use the original inequality. No, the box doesn't mean anything. The line was supposed to be inside the box. I missed by a lot. On like everything. Sorry. Okay, so what I'm going to do is in my calculator, I am going to write this inequality. But instead of the letter x, I'm going to write one of these x values, just one. I'm going to start with -8. Okay? And so make sure that you put your parentheses. Now to get that less than symbol, I'm going to push Control equals. And when I push Control equals, I should see a little menu pop up, and I'm going to select the inequality symbol that I want from that pop-up menu. Once I've selected it, I'm going to continue writing the rest of my equation, or inequality. In this case, it's a 0. I'm going to hit Enter, and it's going to tell me either true or false. What did y'all get?
True.
You got true.
I'm joking.
Oh, you didn't do it. Mentirosa.
False.
False. And I heard that from like a chorus of people.
Do the kinky thingy.
My calculator also showed false. If you're showing true, double check to make sure you've put parentheses around the x. Because if you don't, the calculator is the dumbs when it comes to the squaring thing, and it will square the +8 instead of the -8. And that could cause some issues with your numbers. All right, do the same thing for the other 4 points that remain. And then tell me what you get, true or false. Okay, so do the same thing that you did with -8. Do it with -5, and do it with 1. Sarah, I would love to have a calculator for you to do this with us. Thank you, please. Yes, do this. Oh my God, do this. You're replacing this x on one of these numbers.
Whichever one.
Whichever one you want. Just which one is false?
-5.
-5 is false. All right, so grab a different number.
What?
We're going to rewrite this inequality in your calculator, but instead of x, you're going to put one of those numbers, put parentheses around it. One of these.
If they were
numbers.
positive, would they become true? Would it be true?
Let's check. His question was, if since those numbers are suddenly positive, would it be true? Which one?
1.
1 is true. Okay, let's see if number 2 and 3 is true.
Because I put in the first one and it says error.
It says error. Okay, what did you type in?
You probably typed it wrong.
Value not solution.
I know what
Oh, because did you put an X in there?
Mm-hmm.
Okay, don't put an X, replace X with the number, with one of those numbers. Who's got number 2?
It's false.
2 is false, and so is 3.
Oh, so it's just one.
Okay. Did you get at least one of them done so that you can
Bless
see?
you.
Oh, you did number 2 and you got false also. Okay. -4 worked. Okay. -4 lives somewhere in here, doesn't it? Okay. So it confirms that that space in there between 2 and -5 is going to work for us. Great. Now that we've got all this true and falses, this gives us a very simple coloring map. You have those assignments teacher gives you where you find your answer and then you go into this little coloring page and you find your answer, you color that. It's basically what's happening here, except there's only one color. Here's your coloring map, your key always. If it's true, color it. If it's false, don't color it. That's it. That's your color map for these. All right, this space here, color, no color.
No color.
This circle, color, no color.
No color.
This space, color, no color.
Color.
Color. This circle, no color. This space. I'm done. That's test points. That's it. Look, guys, this test point is going to carry you all the way through to high-end calculus if you go that far. Literally, this is all test points does, is it gives you regions to color. When you're ready, flip the page because let's do this in 2 dimensions when we have an X and a Y. Let's do this one. In order to graph this, I need it in vertex form. I want it to look like that, which means I have to complete the square. All right, I'm going to ignore the greater than or equal to for a moment, and I'm going to ignore the y for a moment. So I'm going to look at just this, and I'm going to complete the square on that equation. First thing to do to complete the square is make sure that a is 1. It is, thank goodness. If it wasn't 1, divide everything by whatever number that's there in a to turn it into a 1, okay? It may give you fractions. That's okay, you can handle fractions. Next thing is I'm going to grab this number c and I'm going to move it over to the other side of the equal sign. When I do that, I'm going to leave myself a space over here between the 8x and the equals because now I'm going to complete the square. To complete the square, grab the coefficient of x, the 8, divide it by 2. Square it. Positive 16. I know because the 4 was negative. But when you square negative 4, it's negative 4 times negative 4. Negative times a negative is a positive. Okay, 16. So I'm going to put the 16 here and over here because it's a balance, and what I do to one side, I have to do to the other side.
Miss,
Yep.
where'd you get 4?
Where did I get 4? I took 8 and I divided by 2.
I didn't do 16.
I squared 4. That was the day 7 completing the square thing. All right, now I'm going to factor the left-hand side. The left-hand side is always going to be stuff squared. And the stuff inside the parentheses is this variable, this sign, and then you remember that we took 8 and divided it by 2? That number. It's factored. That's it. This factoring technique only works when you've completed the square. Please do not attempt to do this on anything that you did not complete the square on. Okay? All right, now I'm going to do negative 7 plus 16, which is 9. And because I want it to look like this thing, this is what I'm after right here, I'm going to move the 9 over to the left, and I'm going to put the y back. And I put the y back just so that it turned it back into a function that then I can graph. When I looked at vertex form, the vertex was located at the point h comma k. Where is this vertex for this function located at?
Do you want us to graph it?
Not yet. Okay. Negative 4, negative 9. I agree with you on the negative 9, but I don't agree on the negative 4. It's a positive 4 because if I look at my original vertex form, the symbol in front of h is negative. And the symbol here in front of the 4 is
Turn it
negative.
positive.
They match, it's a positive. Alright, I'm going to graph this thing now. I know where the vertex is. Time to do some graphing. So I'm gonna throw in some axes. No one cares where you put these things. Your favorite place. I like it centered. That's just me. Alright, and I'm going to graph it. 4, -9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. I want it to be on the grid. I'll count by twos. 2, 4, -2, -4, -6, -8, -9. It fits! I'm so happy. This line right here, this vertical line that goes to the vertex, is also called the axis of symmetry. It's the mirror line. It's where you can fold the parabola and have it end up on itself. This is helpful because as I'm trying to find points on the parabola, all I have to do is one side, because then I can just copy it onto the other side. Okay? So time for me to find some points. Let me find when x is 2 and maybe when x is 0. Okay, so I'll have a point somewhere on this line and a point somewhere on this line. Okay, I'm going to come to this equation. When x is 2, what is the value of y? Okay, x is 2. So now I have 2 minus 4. 2 minus 4 is? -2. I'm going to square -2. 4. I'm going to go 4 minus 9. -5. So when x is 2, my y is -5. And because this is a mirror line, I don't have to think hard for that point. I just reflect it.
Is the parabola compressed?
It does look like it's been vertically stretched, horizontally compressed. Yeah, it does look like it's skinny. I agree. Let's do the same with 0. X is now 0. 0 minus 4 is? Squared is? Minus 9 is? Wait, so we're doing 16
9.
minus 9. Grab the
Seven.
calculator. 7, he says?
7.
7, she says. So when x is 0, y is 7. 2, 4, 6, and 7. And again, because this axis of symmetry is a mirror line, I get that other point for free. I know what my parabola looks like now. Time for me to sketch it. Okay, so it's not the straightest. It's a little wobbly. But that's okay. It gives me an idea of where this thing is. Time to draw the inequality solution. Looking back here, is this colored in the line or is it dashed? Is it included or is it excluded? Included. The parabola itself must be included in the solution. Because the parabola itself must be included in the solution, I must trace it over with a dark heavy line that is solid. If I trace it over with a, ladies, if I trace it over with a dark dashed line, I would be saying the parabola is not included. Okay? We're almost done. I need to know on which side of the parabola I shade on. If I look at this greater than symbol, it feels as if I should shade
Everything
up here, everything above the parabola. So how do I know for sure? I want to be 100% certain I know where I'm coloring. The only way to do that is with test points. When we did this on one dimension, we had 5 test points.
Oh,
The good news is, now that we've gone up a dimension, we only need 2 test points. We need one inside the parabola and one on the other side of the parabola. That's it. So can I please have your favorite test point somewhere here inside the parabola? Any point.
are you still going by twos?
Yeah. 2, 3. So 2, 3. There's the test point that was requested. 2, 3. we're gonna grab our original inequality, and everywhere we have an x, we're gonna put a 2. I'm gonna change that 0 into a y, so everywhere I see a y, I'm gonna put a 3. So head back into your calculators, into the sketch pad, and we're gonna type in this inequality, but this time with this value for x and this value for y. Okay. That's what I typed in. I haven't hit enter yet. What did y'all get? False, false? False. Okay, and when I hit enter, I get false, so I feel comfortable that I did it correctly and I didn't type in something dumb. So I know I'm not coloring inside the parabola. I suspect that means I'm coloring outside, but I should confirm and check. Can I please have a
7.
point? Huh?
Negative 5.
Negative 5.
Negative 7.
Negative 7. Okay, so 2, 4, 5, 2, 4, 6, 7, negative 5, negative 7. We're going to play the same game, only this time x has a value of negative 5, y has a value of negative 7. And when you hit enter, you get how we're getting the true false? Okay. We get a true on this side. Okay, so my suspicions were well founded. That means outside the parabola, I am coloring in, and because it's true. And maybe I should try to be a little more careful when I'm coloring and not get it inside the parabola. That's it. That's all there is to this. Easy enough? Any other questions? That's all I had. Thanks, guys.
Bye.